Thank you very much, Marty. Okay, this session is going to take a quick tour of cloud computing and specifically Microsoft Azure cloud computing offering. Together, the cloud and Azure provide services that basically allow you to accomplish many things, both in your development environments and your production or deployment environments. This presentation today, I'm going to focus on the deployment capabilities that you can achieve with the cloud and Azure, not the development ones. We're going to take a look at the main areas that Azure can be used to help deploy your Synergy applications and interact with Synergy data, all in the cloud. Azure is not the cloud. Azure is simply a provider within the cloud from Microsoft. So they're a big player. No one owns the cloud. It's a collective term for a variety of applications operated by many different organizations, including Microsoft, Google, Apple, and Amazon, and maybe a few more. The cloud, or cloud computing, can be simply explained as someone using someone else's computer on the internet to do something that they previously had to have their own computer to do something for, like storing data or running programs. And just like its meteorological namesake, it's everywhere, or at least it's everywhere where there's a computer and an internet connection. If you don't have an internet connection, you don't have a cloud. We all use the cloud today in our everyday lives. Remember, you take a picture on your phone and it's backed up and stored in the cloud. All sounds very simple. But that now means that pictures are available for you to view, to look at, and to share on any device wherever you are in the world. So you can look at the pictures on your phone, your tablet, your computer, when you're in the office, when you're downstairs at home with your telly on. You no longer have to carry big bundles of pictures around with you, or documents, or even development environments with you anymore. The cloud is free to us all. It doesn't cost anything. Well, it is until you actually use it these days. When you're taking lots of pictures on your phone and then you start getting the storage full message and pay now for unlimited usage and unlimited storage. So yes, the cloud is free to start with, but you all end up paying for something in the end. Nothing's free. And today on Azure you can set up portals and begin cloud computing for free, but you'll soon be paying for what you really need and what you really want to do. The advantage of cloud computing, however, is that you can usually pay by monthly subscriptions, and the amount is quite often based on usage. So you'll pay for what you use and not necessarily what you think you may need. So if you're going to deploy an application in the cloud, or if you're going to deploy an application, you don't need to buy a humongous system with big disks and lots of memory and then find that you're only going to put 2 users on and it's utilized about 2% of what it could actually do. You can create a virtual machine in the cloud and you can scale it up as users increase or the requirement increases. Buzzwords are always associated with the cloud: resilience and scalability. Remember, you take a picture on your iPhone and it's stored in your personal free iCloud. Well, not free because you've already paid the subscription and you paid a fortune for the device in the first place. Imagine the uproar if you got a notification saying, "I'm sorry, we've lost all those lovely pictures you did have because we had a slight problem with our cloud-based computing system. Just go and take a few more, you'll be fine." Not acceptable. There is an expectation that the cloud and iCloud, if you're talking iPhones, and all cloud services are available 24/7, 365 days a year. You very rarely get messages saying, "Do you know what? We're not going to be here for the weekend while you want to do your pictures or do your banking or do whatever, because we're going to have a bit of downtime, do a bit of a backup, tidy up a few things." It doesn't happen. You'll occasionally get banks saying, "You know, we're going to be down for half an hour overnight while we do some maintenance." But generally, it's a 24/7, 365 environment. It's also assumed that your pictures are yours and no one else can access them. And while that is generally true, it's well known there have been many data breaches, but organizations continue to work around the clock to keep your information and my information secure. And if you're in the UK, you'll have been going through GDPR or whatever it is, doing all the data protection stuff. Crazy. So what's the cloud? And it's in a nutshell. And so where does Azure fit into it, the cloud, and how can we as Synergy developers and providers of synergy-based applications take advantage of the cloud? Well, Microsoft has 4 main types, and don't you just love all the little acronyms? Can we all rhyme off what they all mean? No, I can't either. That's a little bit better. Infrastructure as a service is where you are responsible for everything except the physical hardware. From an Azure IaaS configuration, Microsoft provides all the computing hardware, the solid-state disk drives, the network cards, the cabling, the power supply, everything. Services as part of this category include virtual machines. You can create an instance of almost any type of hardware or virtual machine and hardware configuration that you require. What disks do you require? What processors? What cores? What memory, etc. And you put the chosen operating system on. Because it's Microsoft, you'd think it was Windows, but Azure handles Windows and Linux and other operating systems. So you're not just restricted to Microsoft on Azure. Once you configure the virtual machine, you're then responsible for everything on it, except the physical hardware, the operating system, software installations, backups, etc. It's your machine running on somebody else's hardware. You can change the hardware, you can add memory, you can increase disk space. You'll pay for those increases, but you can still do it. And for this service, you pay for what you configure, even if you don't use it. So if you put in gigabytes of memory and oodles of disk space and lots of cores and mega processing, and then you put one user on it to run Notepad, you're going to be paying a lot of money for a lot of machine that isn't really being used. And if your VM is running for 8 to 10 hours a day, depending on how many people are using it, that VM is still running overnight when they're not doing anything, and you pay for that time. One abstract level above IaaS is PaaS, Platform as a Service. In this model, you're responsible for your application only. You don't, in fact, and can't configure the server or the operating system. You do have some basic server configuration capabilities like scaling and pricing tiers and the number of instances that where your application can run, but that's about it. Next, function as a service, FaaS, also known as serverless functions. These are quite cool. In a nutshell, you create an application or business logic and you run it. You don't worry about the hardware or the operating system, and it's all managed for you. Function as a service has one noteworthy benefit here. You only pay when you use it. So you'll set it up, you'll configure it, you'll deploy it, but you won't pay for it until somebody actually connects to your service and runs. And you pay for that runtime. And it generally can be the most cost-effective way of running your applications. But it obviously depends on the type of applications that on what you're doing, what you've got and what you're doing. Now, FaaS does more than just host your application. It gives you access to some cool Azure stuff out of the box, like webhooks that can be triggers and call into your logic without you having to write any activation code. So if somebody tweets something good about you or your company or application, you can have a webhook that can listen to that and process it accordingly. And finally, software as a service, SaaS. This is where you simply configure the software options you wish to use and away you go. You can interact with artificial intelligence services and create fully customized solutions for common Internet of Things scenarios. One of the best known Azure SaaS applications suites is Office 365 from Microsoft. Obviously that offers business applications like Word, Excel and the amazing PowerPoint that we're using throughout this week. It's available via a sign-up service. There's no installation. You don't have to install any hardware or any software. It's all browser-based, and your documents are shared across all the devices that you connect up with. So do you think Azure is right for you? Maybe so. Azure comes with a vast array of intelligent services that allow you to build out your future application solutions while maximizing your investment in Synergy and the terabytes or even petabytes of data that those millions of lines of Synergy code can access around the world every single day. But your cell-based or Windows-based applications may be restricting the growth of your software solutions, and this is where Azure can help. Azure enables access to cloud computing, offering small to large computing footprints with pricing structures to suit. Microsoft also provides a guarantee of uptime of 99.9% service levels, and that can actually increase to 99.99% of service levels, depending on the level of service agreement and the amount you pay. So let's dig deeper into the types of cloud computing services available to us today. Virtual machines. Virtual machines are the cloud, full stop, end of story. Okay, well, not really, but they are a big part of it. Azure Virtual Machines, or VMs, are one of the several types of on-demand scalable computing capabilities or resources Microsoft Azure offers. Generally, if you need complete control over the environment, the hardware configuration, the operating system you want to run on, the software you want to install on it, you would create an Azure Virtual Machine. You get to create and configure the machine you require without having to go to the hardware OS, etc. But you remain responsible for maintaining it. You can create both Windows and Linux virtual machines, so you're not restricted to Windows even though it's a Microsoft Azure service. There's loads of templates. You create virtual machines from these templates. You're given a choice of various templates, and you can even create your own pre-configured templates for various environments. Why invest today in the hardware, maintenance and running costs associated with on-premises machines and data centers in your businesses when you can run your applications and simply host them in the cloud? When you create the VM, you need to name it, and that name has to be unique, and not just for you, that's unique across Azure. So you have to get a bit creative sometimes. Luckily, nobody was using DevPartner VM. You also specify where in the world you would like your VM host. There's no point putting a virtual machine in North America, for example, if you've got users connecting live from the UK. Put it in Europe, put it in UK, put it in the East Coast of America, put it on the West Coast. And consider sizing the VM, the number of cores, amount of memory, etc. Remember that you pay for what you have here, whether you use it or not. Don't make it bigger than you need unless you're happy paying for that privilege. If you've got lots of money, make it as big as you can. VMs are not just for customers. You can create VMs in the cloud for doing deployment, development testing, basically anything you require. You can spin it up, you can create it and spin it up, do your testing and spin it down again. And virtual networks allow you to connect VMs together, and you can also connect those VMs back to your on-premises computers if you still have them, so you can configure the Synergy licensing for all your required Synergy software. This is my Azure portal. It's quite a busy screen actually, and there's lots and lots of stuff going on there. All these services are created, up and running, and costing me a small fortune. Well, they're costing Bill a small fortune. Here you can see the DevPartner Watch Me live app service, which is currently serving all the people who are using the live feed in the room and following the presentation. If you attended the pre-conference workshop and you got to the finish line, you had a Synergy app using Bing Maps. And you can see here the resource I created. Yeah, DevPartner Maps. I created to enable this to happen. This was needed to allow you to use the Bing Maps service. You can manage all your services and resources through the portal, and you can also use them through PowerShell. So creating a new virtual machine is rather simple, straightforward and easy. Within the portal there's a Create New Resource option. Simply click it. When you're presented with a whole bunch of things, you can create, obviously, we are going to create a new Windows Server 2016 virtual machine. Now, they're not listed here, unfortunately, but there are a whole other host of virtual machines that you can create. Windows 10, for example, if you're a developer, you don't need to create servers. They have workstation VMs as well. Basically, the subscription is how you're going to pay for it. But if you've got an MSDN subscription, you get $100, $150 a month free. And when I'm not doing conferences like this, I tend to stick within my $100, $150 a month, so it doesn't actually cost me anything other than my $2,500 a year MSDN subscription. The resource group identifies a collection of resources that share the same life cycle, permissions and policies. Then we can get into the actual VM details. We have to name it, and that name has to be unique. Which obviously ours is, DevPartner 2018, I think we called our virtual machine. Yep. We can tell her where to host it, as I said. anywhere in the world, pretty much. I think they've got about 50 plus different hosting sites around the world. But best to be nearer where you're going to consume it or where it's going to be used from. And then you obviously pick what sort of image you want, Windows servers, Linux, Windows 10s, etc. And then you need some details so you can actually physically log in, because this is going to be the equivalent of a machine that you've physically got in front of you. You can watch the progress as it creates the virtual machine. It literally only takes a few minutes and it'll be up and running. It's pretty frightening how quick it is, actually. And if you're in the portal, you can dismiss this and you'll get various notifications inside the portal as it's saying, I'm building this, I'm doing that, I'm building this. You can review and use the connection details to connect to the virtual machine, so you've got an IP address and a port number. Now our virtual machine is up and running and we can configure our Synergy environment. So we can RDP into it and make a connection directly onto the virtual machine, because I've opened up the required RDP port. Obviously, opening ports is not the recommended configuration, and basically you really want to configure a VNet and a virtual private network to give you the right security. But for this purpose, I literally set up the RDP. Then we configured Synergy, and then we can connect to the RDP. Once we're connected to the virtual machine, we can run our Synergy applications that we've got installed. And for those who came to the pre-conference on Monday, you created a simple vinyl browser. So I can now connect through to my virtual machine. So that's my DevPartner VM, and I've installed Synergy, I've installed my Synergy application, and it runs. So I've now got cloud computing for Synergy, and it's costing me pennies a day to run it. And it's a server, so you can have multiple people connecting, and life is good. So that's it. Okay, so let's talk about platform for a service. In a nutshell, you deploy your application and configure it and leave everything else to Azure. Azure Cloud manages the operating system and the hardware it runs on, and you have no control really over any aspects of those. Some of the services that fall under the platform as a service umbrella are the Azure App Services. The App Services allow you to quickly build and deploy enterprise-grade web and mobile applications directly from within Visual Studio to the cloud. And it's a seamless way of doing it. You build, deploy, and configure applications and let Azure Cloud basically just do the rest for you. Your application still runs on a server or servers, but you can't specify the locations of those servers. Sorry, you can specify the locations of the servers, but you aren't responsible for the servers, unlike the infrastructure as a service. This means you use your time developing your application and not managing the server it's deployed on. You leave somebody else to worry about that, and that somebody else is called Microsoft. The Azure SQL database is a fully managed relational database in the cloud. Why not replicate your Synergy ISAM data to a cloud-based SQL database and remove the need to manage database in-house, on-prem? Leave that up to somebody else. And we'll see about encryption in that in a minute. Like creating the virtual machine, creating a web app could not be simpler with Azure. Visual Studio is the tool of choice, as it is with Synergy development. It's the same with this. Given you're all using Visual Studio for your Synergy development, both traditional and .NET today, you've already got the tools to get started. Synergy itself doesn't have templates for web applications, so we're going to use C#. No harm in that. We'll select something simple like an ASP.NET web app, as we're doing in the image on the screen. After electing to create the web app, you've got a number of choices here. We've got several project types, including web forms, as you can see, MVC, and single-page applications. Guess where I started my single-page applications for this morning's session? I went into Visual Studio and I did these exact steps. For our simple website, we're going to create an empty site. We just want a website that we can add to later. It only takes a few seconds for Visual Studio to create our project from the templates we selected. But once we have the basic empty website we can create our first web page, and we're going to call it default.html. Then we're going to make sure we set Default.html as a startup page, so at least when we run the website, we're going to see something. And then we'll add a few lines of HTML to the default.html page. And basically, it just says, hello attendees, which is you lot. So I'm not saying hello to myself, I'm just saying hello to you guys. And we can run and test this locally, of course, and check what we have done and what it actually looks like and that it all looks pretty and great and wonderful. Now we've got the completed, fully functional website, although it just says hello attendees. We can publish it to Azure. Again, it's another couple of simple steps and just a few questions. You need to name the instance, and that has to be unique across Azure again. Again, the subscription is how you're going to pay for it. The resource group identifies the collection of resources that share the permissions and policies, because you can provide things like Active Directory policies to enable who can and can't run this kind of stuff. The hosting plan defines where the hosted service will execute: Europe, America, North America, etc. Once you click the Create button, you're basically going to create a live website. And it really is not much harder than that. Make changes to your website, you simply publish those changes. When you created it, it gave you a name, and that name becomes the URL to access the website. And you can see here the address http DevPartner Web App 2018.azurewebsites.net. Clicking the Publish button simply takes whatever changes you've made into your Azure website and publishes it to the cloud. And it really is that simple. Okay. Function as a service. I like these. You don't concern yourself again about the hardware and the operating system, so it sounds like PAS, PAS. But you also don't concern yourself about scaling the resource. Scaling happens automatically for you, and when you use it and when you need it. You don't have to say, oh, I think so many people will be coming on to use my website or to use my serverless functions, therefore I'll pre-scale it. It just happens sort of automatically under the hood. The biggest advantage of FAS is the payment model. You pay for what you use when you use it. With the previous cloud computing types that I've shown, you pay for the instance. So once you've set it up, once you've configured it, once you've published it, once you've created the virtual machine, you start paying for it. With FAS, the service is always there, but you only pay for it when you or your customers or your consumers actually use it. And it basically responds to requests or events, but you only pay for when those events or when that code is actually executing. FAS allows you to connect basically your business logic and data when events happen. Now that event can be when a request for a resource is actioned or a timed trigger event happens. At this point your code runs and you pay for that execution time. And the amount of time it executes is the amount of money you'll pay. And this can be a very cost-effective way of doing cloud computing. So how do we go about building serverless functions with Azure? Guess what? It's dead easy and it's all in Visual Studio. We create the Azure functions using templates, again available in Visual Studio 2017. Again, Synergy, we don't have these templates, so we're going to use C#. And we'll call our project DevPartner 2018 Functions, because it's a nice, meaningful name. There are a number of different function types. The timer trigger template creates a function that will fire given a specific time. You may want to do something every 5 minutes, every hour, every day, every week, every month. Whatever that time is, you can create a timer. We're going to create a HTTP trigger. The HTTP trigger allows you to invoke a function with a HTTP request, like a RESTful service type request. You can use this to build out our serverless API and respond with some information when the HTTP trigger is executed. When we create the function, it creates a default function called function1. We'll rename that to get application data. And this is the code for our function. Very simple, and it was code generated from the HTTP trigger template. The default code in here simply passes the URI, query string, and if you specify a name on the query string, then we'll say hello to that name. It's simple, but you know, we like simple. One powerful feature of creating the functions through Visual Studio is that you can test them without actually having to go to the cloud and publish your stuff. Everything can be tested locally on your development machine. Running the function from within Visual Studio, and it creates this Azure server environment locally on your development machine. It's like having a local cloud instance ready for you. In the green at the bottom of the screen, you can see the URL that you can use to access your local function. Paste this into a browser on your development machine or testing tool like Postman, and you'll see the results. I've copied and pasted the URL in here into Google and added the name, the question mark name parameter, and put DevPartner, and it's responded with hello DevPartner. That's very nice of it. It's a friendly function, I like to think. It's working, so I can put it live. Guess what? Pushing it live, we've seen these sorts of dialogues before. It's all very straightforward, all very simple. Again, you give it a name, you configure a few other settings for the required deployment model. A few moments later, and you've published your Azure serverless function up to the cloud. It'll be live, it'll be ready to go. You can run the function. You may have noticed on the previous slide the URL was https://devpartner2018functions.azurewebsites.net. And that's what you're navigating to there. Although this is the address of the function, it's not going to give us anything meaningful, other than it just tells you, yes, your function is there, it's up and it's running. It's all fantastic and well that our function is up in the cloud, but it's not much use if it doesn't do anything. There must be a little bit more that we need to do. When you publish the function to Azure, it protects it using a function key. Without the key, you can't run the function. It's as simple as that. So in the portal, you can get the function key. So it'll give you the full key that is obviously all blacked out, and you can copy, and it'll give you the full URL with the key. So now using the function key, we can access the whole URL. So the URL becomes the URL it was and our function key as well as our function name. So now we get hello DevPartner function call responding because that's the information we sent. Now, obviously the code in here is still very simple, but we'll add a bit more to that in a moment. So before we advance our serverless function, let's talk about accessing our application data. In the relay data transfer pattern, the on-premises service connects to outbound, or connects via an outbound port to the relay service on Azure, and creates a bidirectional socket communication between your on-premises machine and your Azure server relay. That means the client can then connect to and communicate with your on-premises data by sending requests to the Azure service, and that relays it back down to via your outbound port through the bidirectional socket down to your on-premises machine or your virtual machine in the cloud. It doesn't have to be on-premises. There's no direct connection between the client and the on-premises machine or the virtual machine that your application's running on. Now, for the purpose of my session, I don't have an on-premises machine. The on-premise machine is my virtual machine that I've just shown you running in the cloud with my little Synergy Toolkit application on. But it can be configured this way, and it allows your virtual machine then to talk to the service relay, and the service relay accept inbound clients coming in. It's a very safe and secure way of doing it. Remember also from the previous slide we had a function key. We need to provide that function key when we action the functions. No function key, no function execution. Now the function key is considered one of your secrets, and as such you need to keep it safe. And you need to store it somewhere. Now you can write it down on a piece of paper and give it to every developer and they can remember it and put it into the code, and that's not really very good. And actually when you're writing code, you really don't want to embed the function key secrets inside your code, but you want to access it dynamically from a source, and that source can be an Azure Key Vault. The Azure Key Vault allows you to basically safeguard cryptographic keys and other secrets used by your applications and services. And by storing your keys in the Key Vault, you not only improve your security of your applications, but you also reduce the need to recode. If your security key needs to be changed, you change it in the vault, you don't change it in each individual software element that you've written. So there's less to maintain, and it's basically the admin that then maintains the keys in the Key Vault. So we've created our Azure key to store our function key information in. we can use this in our function to access the required key. We have to register our application within the Azure Active Directory to ensure that the serverless function has the right permissions to see the vault key, which is another security feature. And we created the Service Bus Relay service that I've just been talking about so that we can communicate between our client and our on-premises, or in our instance, our virtual machine data on our private virtual machine, without actually opening any ports and threatening anybody trying to get in. I've created a simple Windows service using Synergy.net to connect to the Service Bus Relay, and that provides the bi-directional communications between my virtual machine and my serverless function up in the Azure cloud. At this point, we've not had to open any ports through the virtual machine, and only our function has access back into this machine to access the data. There's nothing else in the world that can get to my data through any other way than that function going through the Service Bus Relay. Now we've got the Service Bus Relay connection that exposes our application data in a safe and secure way. We can now access that from our serverless web function. The load async method will connect to the relay service and access the data required. And the data will be sent back to our consuming Azure Web Service. To our Azure Web Service site, we can simply add an active server page form. I talked a lot about single application pages today. This is an active server page. In the page load event, which is all happening on the server, that's where we can do the logic that gets the key, uses the key vault to get at the secret key that we use to call the function. Then we can build up the function call. Then we can call the function and access our live data on our production machine. Finally, software as a service. Software as a service is basically the highest abstraction level of cloud computing types. With SaaS, you only concern yourself with configuring the software and nothing else. Office 365 from Microsoft is a premium SaaS application offering basically cloud-based access to business tools like Word and Excel. And with the SaaS software, you're just ready to run. It's all pre-configured for you. You don't need to worry about the hardware, the operating system, the application. You just configure the bits you want to see, whether you want to have access to Word and Excel and PowerPoint or just one or the other of them. You don't need a machine other than a device that will actually connect to the internet. So that could be a computer, a laptop, a browser, a phone. It really doesn't matter because you don't install anything. And usually we pay by subscription and not usage. So it's not a case of, oh, every time I write a document I'll pay for it. No, you pay by subscription. Some of the other features and offerings from Microsoft, and there are millions of them. I mean, I mentioned earlier about Azure Active Directory. This service provides sort of out of the box the ability to authenticate users for your systems. You can also provide authentication for your applications and use resources within Azure namespaces. So certain applications can have access to certain key vaults, etc. Azure Web Application Firewall can detect and block malicious attacks from reaching your systems and report on what attacks were attempted. By default, you store data in Azure SQL databases. For example, on an Azure database for MySQL, the data is all encrypted without the need for any configuration type whatsoever. So if you need to be, what is it over here called, HIPAA compliant, that kind of stuff all just happens for you. When you start digging down to Azure, there's a vast array of resources and services, and it is growing all the time. If I put a slide together last week, it'll be out of date this week because there's so much more happening. And these services combine together to allow you to add capabilities to your Synergy application, like we did with Bing Maps on Monday, like we did with a serverless function today, calling back through a secure connection to your database, on-prem or a virtual machine. And that's me done. Thank you for your time. If there are any questions.
Can you make that URL more user-friendly or use a custom domain name, or does it have to be azurewebsites.net?
I believe you can make it more user-friendly by using a custom domain name, yes.
Okay. Is there a latency concern when function as a service functions are called versus a running instance?
Is there a delay? Yes, there is, and it depends on your deployment model. There is a delay with mine because I've got the cheap version of deployment model, which is a zip file, and it sort of unzips it and runs it. You can deploy it, sort of run now deployment.
Okay. can you have multiple functions in a single function as a service instance?
Multiple functions in a single service function instance? Yes, you can. Yes, you can.